Hello, everyone. While sipping my morning coffee, a rather odd idea suddenly came to me. Combining a positive electrical plug with a kitchen strainer to make a homemade antenna. Strange, yes, but that's what makes it fun. So let's give it a try. The first thing I do is use pliers to bend off a section of the strainer's handle. Once the metal core is exposed, the two contact points become much easier to connect to the electrical plug. And the idea of turning this kitchen strainer into the signal receiving component of an antenna might sound amusing at first, but the actual effectiveness is surprisingly strong. To explain this in a more formal doctoral thesis level manner, there is solid scientific reasoning behind it. First, most strainers are made of stainless steel or conductive alloys. Their mesh construction forms a repeating array of small metallic cells, which behave similarly to the element grid used in antenna arrays. These repeating units enhance signal capture through surface resonance effects, much like the way modern antennas leverage fractal or mesh-based geometries to improve gain and bandwidth. Second, the natural concave shape of the strainer promotes internal reflection of electromagnetic waves. This increases energy concentration at the connection point, functioning somewhat like a miniature parabolic dish. Although smaller and used for lower frequencies, the underlying physics remains the same. Multiple internal reflections improve directivity and overall signal strength. Several experimental studies have shown that even a shallow curved reflector can meaningfully enhance antenna performance. Third, the positive electrical plug provides a stable metallic contact point, minimizing conduction loss at the junction. In numerous RF transmission studies, junction stability is considered a critical factor in preventing signal distortion. The combination of the strainer and the plug creates a surprisingly efficient connection that can be assembled easily with common tools, fitting neatly into the principles of practical DIY engineering. Finally, many research projects have demonstrated that unconventional structures, even everyday household objects, can function effectively as antennas due to basic principles of diffraction, reflection, and electromagnetic resonance. Since 2014, various experiments involving spoons, metal trays, and wire mesh have shown remarkable reception capabilities. In that context, using a kitchen strainer is not humorous at all. Rather, it is a compelling experimental example of how versatile conductive materials can be in signal reception. This is an electrical outlet. Hard to find a better base of the antenna. I'll open the cover of the outlet to route the coaxial cable, preparing to connect the plug assembly to the strainer antenna element. This setup is both stable and keeps the components fixed, while ensuring that the signal transmitted through the coaxial cable remains steady. For electrical safety, I'm using a heat shrink tube instead of electrical tape. It not only provides excellent insulation, but also looks neater and more professional. When heated, the tube tightly wraps around the connection, securing components and reducing the risk of accidental contact, making it both safe and visually tidy. At the end of this coaxial cable, I'll attach a straight F connector and a 90-degree F connector. The purpose is to allow the cable to connect directly to the TV easily, while providing flexibility in positioning the antenna without interfering with surrounding space. All right, it's all finished. I can't wait any longer. Let's take the antenna outside and test it with the TV right away. I'm really excited, and I hope everything works as intended. Within the first 4 seconds of connecting the device to the TV screen, we can see the signal, but we can't draw any conclusions just yet. So we'll wait a little longer to see if everything stabilizes. So far, we've waited a short while and haven't noticed any signal issues, right? Now I'll move behind the TV, unplug the cable, and plug it back in to ensure a more stable connection. By now, I can conclude that it's a success. The signal is stable, the picture is clear, and it's amazing to see that with just a few simple household items, we can create something truly useful. DIY is not just experimentation. It's a joy of discovery and creativity. If you enjoyed this video, be sure to like, share, and leave a comment. I'm excited to see what ideas you'll try next.